All right, hello. The topic for this section is radicals in rational exponents. So our essential question is, how can we write and evaluate an nth root of a number? You have some knowledge with this already. For example, you know what a square root is. This is an nth root where n is 2. So the square root of, say, 25, you know this can be positive or negative 5, because 5 squared or negative 5 squared is 25. Therefore, 5 is an nth root of a number. 5 is the square root of the number 25. So our learning objective, we're going to explore the relationship between fractional exponents and radicals. We're going to find nth roots of real numbers, and then we're going to evaluate expressions with rational exponents and nth roots. So first, we'll talk through this intro. 8 yards of gravel. What do you think that looks like? Whenever people talk about gravel, they're talking about cubic yards. So 8 yards of gravel actually means 8 cubic yards. So for example, if the gravel were dumped inside a cube-shaped container, what would the dimensions of the cube be? So if we've got our gravel inside of a cube, and all 8 cubic yards fits inside this cube, the dimensions would have to be the length times the width times the height. But this is a cube, friends, so that means every single dimension is the same. So length equals the width equals the height. So we need something times something times something that equals 8. And that something is 2. So each of these dimensions are 2 yards, 2 yards, and 2 yards. Now in feet, remember there are 3 feet per yard. So each of those 2 yards becomes 6 feet by 6 feet by 6 feet. And now the volume in cubic feet, well, I guess our notation of writing 6 by 6 by 6 tells us the volume. This is 6 cubed, which is 216 cubic feet. So that means 8 yards is 216 cubic feet. So this section we're going to talk a lot about cube roots and cubing things. So for example, 6 cubed is 216. The cube root of 216 is 6. So in a sense, think about roots as undoing exponents. And we'll talk about more as we go on. So let's go forward with some vocab. Nth root of a. For an integer, remember integer is a positive or negative whole number. Think negative 3, negative 2, negative 1, 0, 1, 2, 3. For an integer n greater than 1, if b to the n equals a, then b is an nth root of a. All right, that's a lot of letters. So we know what 2 cubed is, right? 2 times 2 times 2, that is 8. This means we have something to an exponent equals something. This means 2 is a cubic root, or a cube root, of 8. To write the equivalent statement of 2 is a cubic root of 8, we can write this as a radical, which is an expression in the form n root of a. So you know about square roots, but there are also, we can find nth roots. So for example, the cube root of 8 means what cubed equals 8? And that's 2. And now some vocab. The index of a radical is this value n in the radical. So in this above example, the index is the value of n in the radical. So this index is 3. And now square root, this is something that you know. This is a radical expression with an index of 2. We often don't write the 2. So for example, the square root of 4, this is the same as the square root of 4, with or without the 2. If you don't see a number here, you can assume that it's a square root. But if it's anything but a square root, if it's a cube root, if it's a fourth root, if it's a fifth root, there will be that number right here. All right, so that's the vocab. We'll keep going. If you have any questions about that, just go ahead and email me. Okay, now recall that you cube a number as follows. 2 to the third power equals 2 times 2 times 2, which equals 8. So we say 2 cubed is 8. Remember that exponents are just repeated multiplication, unless the exponent is negative, and then it's repeated division. All right, now to undo cubing a number, we take the cube root of the number. So the cube root of 8 means the cube root of something cubed, in that case is 2, so this is 2. The cube root of 8 is 2. It's undoing this exponent here. So this means the cube root of 8 is 2, which means 2 cubed is 8. They undo each other. All right. Okay. Real roots of a base. If n is an integer, and remember we're talking about this, the nth root of a, and this key, I'm going to write this as the star. This is a to the 1 over n. So, as a side note, square root of 4 is equal to 4 to the 1/2 power. Same value, just different ways to write the same thing. Okay, now, these two are key here. If n is odd, so if it's 1, 3, 5, 7, 9, that means a has one real nth root. So for example, let's do the cube root of 27. This means, what cubed is 27? This is 3, and you get 1 root 3. This can't be negative 3, it can only be 3. But if n is even, then we have 2 real nth roots, and it'll be the positive or the negative root. So for example, if we take the square root of, let's just do 4. This is equal to 2, because 2 times 2 is 4, and it's also equal to negative 2, because negative 2 times negative 2 equals 4. So that's why we write this plus minus here when we after a square root or after a fourth root or a sixth root, we would end up with 2 different answers, 2 possible roots. Now this guy, if n is even and a equals 0, then a has 1 real nth root, which is 0. So this means that the square root of 0 is equal to 0. The cubic root of 0 is 0. The fourth root of 0 is 0. And this makes sense if you think about it, because 0 squared is still 0. 0 to the third power is still 0. All right, now let's keep going. Let's make a conjecture. What is the relationship between rational exponents and radicals? So we have this rational exponent, so some number to a fraction, 1 over n. This is the same thing as taking the nth root of that number a. So this is 2 different ways to represent the same value. 2 different ways to represent the same value. So this means that 2 to the 1/3 power is equal to the cube root of 2. Same thing, just 2 different ways to write it. All right, let's find some nth roots of these real numbers a. Number 8, yes, numbers a. All right, if n is 3 and a is negative 64, that means we are taking the third root, the cubic root, of a number negative 64. So this means what cubed is negative 64? Think about it. This is negative 4. This means that the cube root of negative 64 is negative 4 because, I'll write it down here, negative 4 cubed is negative 64. All right, and remember that this is odd, so we get 1 root. Now, part B, n is 2, a is 81. That means we are taking the square root of 81. All right, class, this is even. The index of the radical is even, so we're going to see an answer that has a plus or minus. So we're going to end up with 2 roots. So 2 roots. All right, square root of 81. I'm guessing 9 immediately popped into your head, but don't forget about negative 9. So our answer is plus or minus 9. Or you could write this as 9 comma negative 9. So both answers is fine as well. If you prefer to use 2 different numbers instead of writing this symbol. All right, email me if you have any questions about these. Let's keep going. Objective 3, I can evaluate nth root expressions. All right, the 4th root of 81. All right, is this even or odd? It's even. The index is even, which means we're going to have a plus or minus. It's going to have 2 roots. The 4th root of 81, that means what to the 4th power is 81? And class, that is 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. Now this guy, it's the same radical, but we threw a negative out front. So this is negative plus or minus 3, which is so many symbols. But hey, this is really still just plus or minus 3, because if our 3 was positive, this negative makes it negative. If our 3 was negative, and this negative, negates the negative, and it becomes a positive. So we still end up with 2 answers. We still have a positive and a negative 3. So this answer is also positive or negative 3. And now we have a fractional exponent in part C. So remember, 25 to the 1/2 power, that's the same as taking this denominator and putting it as our index of the radical. So this is the same thing as saying the square root of 25, which is equal to plus or minus 5. Right on. Now D, very similar to C, but with a negative 25. Now really think about this one for a second. Is your answer 5? Is 5 times 5 negative 25? No. What if it were 5 or negative 5? What's negative 5 times negative 5? Hold up, that's still a positive 25. What multiplied by the same thing is negative 25? Class, this is not something we know how to do yet. This gets us a not real number. This gets us an imaginary number. Ooh. And, okay, an imaginary number, by definition, is called I, and that's equal to the square root of negative 1, because we don't have this is how we define square root of negative 1. Because so far we haven't had a definition for what happens when you take the square root of a negative number. And we're going to talk about this later on in the course. I will not assess you on this. I just wanted to sort of introduce this idea to you now as we're talking about square roots, because this is where this imaginary number shows up, is the square root of negative 1. So this answer is actually 5 times I, which is not a real number. It is an imaginary number. So this is its root, 5i, and that's that. And that is it for this little objective 3, evaluating nth root expressions. You'll get lots more practice with that on big ideas and in class. All right. Now let's take a look at this. This is key. This is a big idea here. Let a to the 1 over n power be an nth root of a, and m is a positive integer. Okay, we're going to say a to the m divided by n. So let's just look at this example. 27 to the 2/3 power. We're going to talk about fraction powers that don't have a 1 in the numerator. Whoa. Rules of exponents, class. This 27 is the base, it stays the same. We can break this fraction into two parts. We can break it into a 1/3 and it's squared. Because this is really, if you multiply these together, if you multiply 1/3 times 2, you get 2/3, which is this over here. So from this step to this step, all we're doing is breaking apart this fraction, which we are allowed to do due to laws of exponents. And now we know what 27 to the 1/3 power is, because that's the cube root of 27. And then we have to square it. So if we want to actually solve this one, this is the cube root of 27, which is 3, squared, which is 9. And we can do this no matter the situation. So if we have 243 to the 2/5 power, this is the 5th root of 243 quantity squared. Keep in mind that whatever is in your denominator here, so this 5, that becomes the index of our radical. And then this, whatever's in the numerator, that's just a normal exponent. So the 5th root of 243 is 3, actually. So this is just 3 squared, which equals 9. And now we have 16 to the 3/2. So this 2 is in the denominator, so that means we're going to take the square root of 16 and then cube this. So this is 4 cubed, which is 64. And I suppose I should add a step here for these. So this is really 16 to the 1/2 cubed. So I should have added a step here and then broken it down to a square root, if that makes more sense to you. And then in this next part, I'll let you do this on your own. In your own words, describe how you can evaluate expressions with rational exponents. So put this into words. Just describe how you can split up this fraction into a 1 over a number and then 2 an exponent. And that helps us find an nth root first and then cube it. But hey, you could also do this the opposite way. You could also cube it first and then find the square root. So we could have done 16 cubed to the 1/2 power. It's all the same. That's more difficult to do in your head because I can't do 16 cubed in my head. But then you would square root it and you should get the same thing. You should get 64. So it doesn't matter what order you do. It doesn't matter if you take it to the exponent first and then to the root, or if you find the root first and then raise it to the exponent. It doesn't matter as long as you have the nth root, the n value correct, and then your exponent value correct. All right, so I'll let you do that on your own. And we got 2 last problems here. So we're just going to solve this problem quick here. So the radius r of a sphere is given by the equation r equals 3v over 4 pi to the 1/3 power, which is just the volume formula rearranged to solve for the radius. That's all this is. It looks scary, but it's just the volume formula rearranged so that we solve for r. The volume of this basketball, 463 cubic inches. Let's find the radius of the basketball to the nearest inch. We're going to use 3.14 per pi. Okay, so this just means we're going to plug in some variables. So r equals 3 times v. So remember, I'm just using this. 3 times v, the volume, which is 463 over 4 pi to the 1/3 power. In other words, the cube root power. So I'm going to go ahead and type into my calculator 3 times 463. this is equal to 1389 all over 4 pi, which is about 12 point, I'm going to go 566. I always like going 3 decimal places. You get a pretty close answer if you do that. All right, now I'm going to take 1389 divided by 12.566, and this is to the 1/3 power class. I'm also going to do this in this step. So this is the cube root of 1389 divided by 12.566, which is 110.536. I'm going to take the cube root of that. So in my calculator, or in Desmos, you can do this. In my calculator, I actually took this to an exponent of 1/3 instead of doing a root. But you can also do a root in your calculator. If you need help with that, just let me know. Just email me. So this is 4.799-ish inches. And that's the radius of this basketball. Almost 5 inches. So exponents show up all the time when talking about anything three-dimensional, because volume is dealing with cubic items. So the volume of a sphere is going to be something in cubic inches, which is by definition a cube, like the cubic unit. So we're going to deal lots with cube exponents and cube roots when we deal with figures like, or objects like that. Okay, and now we're going to talk about interest. The annual inflation rate R of an item that increases in value. So this is an inflation rate. So we've got an item that increases in value from P to F. So for example, bread has increased in price over the past 10 years, just as everything else. Over a period of n years, we can use this equation. The inflation rate R equals the new price, like the current price of the item, divided by the old price of the item, to the 1 over n power, where n is a period of time in years, minus 1. Find the annual inflation rate to the nearest 1/10 of a percent of a house that increases in value from 300,000 to 360,000 over a period of 8 years. All right, y'all. So inflation rate R equals F divided by P to the 1 over n minus 1. This 360, that's the new price. So this will be our F. And this is our old price, so this will be our value P. In this 8 years, this is our N. So we've got all of our variables, so we're looking for the rate of 360,000 divided by 300,000 to the 1/8 power, because we're 8 going in 8 years, minus 1. All right, I'm going to take 360 divided by 300,000, and this is 1.2 to the 1/8 power minus 1. All right, now using our calculator, 1.2 to the 1 divided by 8 power, that is 1.023 minus 1. Don't forget about this 1. Now, so this means that the inflation rate is 0.023, but this is a decimal. So let's find to the nearest 1/10 of a percent. So, for a percent, we move the decimal place to the right 2. In other words, we multiply 100 because the whole of a percent is 100, not 1. So this is really 2.3% inflation rate. Pretty cool, huh? So now you can go look up prices of bread over the years and figure out the inflation rate of our common items that we all purchase, which is always fun. It's always fun to hear how how people from, the 60s and 70s, how much they had to pay for things. Okay, that's it. Lots of applications of exponents. Exponents are really everywhere, y'all. So Actually, in our next section too, we're going to really dive into applications of exponents and exponential functions. So, but that's it for this section. Email me if you have any questions on the notes or big ideas or the learning check. Just let me know what you need. All right? Have a great